Hello everyone, how are you? So I'm going to talk, not as eloquently as Daniel, about basically some side projects that I've been working on. I am a software engineer by trade at YLD here. So I usually work on site with clients, working with basically their tech stacks, kind of working towards kind of a shared goal of what a company is trying to deliver. Generally, I am a software engineer, so I develop programs, I build infrastructure, and I kind of want to move into this kind of, into data, into machine learning, and trying to understand kind of the field more. And the one way about that, how I tend to do that, is to talk and kind of do stuff on my own and be told that I'm doing things in crazy or silly ways and how I should learn a new direction. So if you, at the end, if you know about any kind of ways that I'm doing things wrong, or different ideas that you might have, or different methods that I can kind of apply to it, reach me out, tell me, and I will learn, and hopefully we can share it later on. So happiness, I'm going to talk through some tooling, the model that I'm creating, and the implementation, and then possible next steps as well. So the plan, right? So the idea is to take a history of public track messages and run them through my model, and basically score happiness in chat as time progresses throughout history. Ideally, I wanted to kind of find patterns in if there's any kind of particular things that cause happiness, like a Wednesday hump day. If it's like middle of the week, people are starting to be a bit down. Does like messages become a bit more aggressive, terse, and does that flag up? This is step one, the analytics stage. Step two, I want to kind of then do it on a like real-time basis, so listen to messages from Slack, pull data in, understand it on that kind of cadence, and then maybe do other things that Daniel mentioned as well, because I'm just jumping on the back of his talk because I can. So I'm going to be calculating this thing called a happiness score. This would be a value of kind of weighted predictions between kind of anger, emotion, joy, fear, sadness, love. So this was my idea, like how do I come to realize this? So I was kind of like, well, I code for a living, and here the problem isn't code. I can do coding, I can learn languages, but I don't want to spend all my time fiddling around with learning Python because I don't know Python, or learning a new framework like TensorFlow. Although that's what I initially did when I started learning machine learning. I was like, I have to learn all these programming tools. I have to learn how to utilize TensorFlow, how to understand all of the different functions and methods, etc. But I didn't really want to do that for this kind of tool. So it still uses TensorFlow under the hood, and a lot of the parameters will be exposed as well. But mainly I'm going to look at a way of doing this by just focusing on the data, the model, and then the basically data augmentation and manipulation. So I'm going to focus on using CSVs, YAML, a tooling called Ludwig, and a little bit of data processing with CLI tools called JQ and MLR, which allows you to handle JSON and CSVs nicely. So the tooling that I'm going to be using is Ludwig. I don't know if anyone's kind of seen or heard this. I don't know how popular it is, but it's tooling built by Uber, particularly to basically allow people to build models without having to code. So that's kind of defining inputs and outputs, having a set of predefined models that they've built themselves, and allowing kind of the operator to compose these models together to produce new outputs. Ludwig utilizes TensorFlow underneath. So even though Ludwig is there, the model that actually exports is a serving model, so you can actually build on that with real TensorFlow code later on and kind of extend the model and basically play around with kind of weightings, etc. Stuff that I don't really know too much about, but I know that you can play around with it. And third thing, data input. CSVs are easy to create and read. And basically, Ludwig works mostly on CSV data. It does support data frames if you use the APIs itself, but in this case, I just wanted to use CSVs, which is like labeled columns with tagged data. So it is kind of a supervised learning in the sense that I provided a list of training data with tagged data sources. And then based on that, we will define a model, which is a simple YAML file, which is just a text descriptive language, if you don't know what that is. And then hopefully we get an output. So the first problem I came across, which is when I was going through a load of tutorials and trying to understand machine learning, it was like, oh, right, yeah, here's 1,000 images or 100,000 images of numbers from 0 to 9. Plug that into a piece of code that you've written. Super simple, it makes a lot of sense. And look, you've got a classifier that can figure out the actual digits from an image. And I'm like, oh yeah, I understand it, I can build it, I can make stuff work. But then I started thinking, how do I apply this to my own problems? How do I make use of this data? And I couldn't gap that bridge for ages. I just was unable to understand why my data that I'm putting into my models just produces garbage. And the main problem was building a data set. I didn't take any time or effort in building a decent quality data set. I basically just took what I could find and tried to see if it worked, and it never did. So in this case, I did what I usually do. I took some time to kind of make a nice data set, but at the same time, I did just download it off the internet because it's quicker to do it in my own time. But I did search for quite a while to try and find tagged data sets of human emotion and how it kind of portrays in textual information. This is kind of a random sample from there. Some of it makes sense, other of it it's just garbage and it doesn't even make any sense, but it provides a decent enough baseline that I can kind of play around with and feel happy that I'm actually being able to do something that I like. So yeah, it's not the best quality, but it's enough to start building my models on. So now we have my data, I'm just going to try and build a simple model. And honestly, this is the whole model inside of Ludwig. It basically, you define your input features and your output features. Now, on the kind of the Ludwig examples, there's many different ways of doing like multi-label classifications. There's different type of architectures that you can leverage, which have already been built. So you can basically just plug in kind of the data types that you want and know the mappings. Now you do need to, I did have to learn quite a lot about what all of the terms meant and kind of how these kind of domains map against each other and what it actually means to produce an input feature using a parallel CNN. I had to learn what parallel CNN was, how to break down words, etc., and what categories were and how to map them together and how that works in a neural network. And honestly, a lot of the examples, as long as your data follows the same format, for example, you have a load of text, which is kind of NLP-driven, with a load of tagged data, the model is going to transfer from one domain to another. So I have my simple model. I just wanted to train it. So spun up Colab, colab.google.com, which is basically a hosted Jupyter notebook on Google. They provide a beefy GPU for you, allow you to train your data on, so you're able to kind of just build stuff and iterate quickly. This model was able to train in about an hour on my machine, but it's like 2 minutes on one of the Google Colabs, totally free, just spin it up, fantastic, super loved it. So you can see the first batch, I'm getting around 93% accuracy on the train, or about 91% accuracy on the test and validation data, which I was pretty happy with. I'm like, well, just seeing this took a couple of minutes to run and some terrible data, what can go wrong? I've got 90%, woohoo. So to kind of prove that it is actually using TensorFlow underneath, it creates a model, creates a load of hyperparameters, and it places it in a results folder. So you can use TensorBoard to kind of see the basically the training rates, the accuracy over steps, etc. And there's a lot more details and visualizations that Ludwig allows you to pull out. I don't understand most of them, so I was like, let's not talk about that because I don't understand it. But I guess this provides a nice little bit of information that can kind of tell me how my model progressed over time. And once I get to the point where I can start tuning parameters, I can kind of keep running it and seeing how things change over time. And as a visual learner, it makes it a lot more easier to kind of see cause and effect based on things that I tweak. Ideally, automating it, that's the word. Automating it later to kind of do it automatically would be amazing, but that's something for later. So once that was up and running, the most simplest thing, I was like, okay, cool, sweet. Ludwig comes with her own HTTP server that's built into it. Run that against the model that I created, which came out of that experiment. It's the second run this time. Curl that HTTP endpoint that it starts up, and I start getting predictions out. So I send through the text, this is fantastic, and I get a prediction of 90% accuracy of joy. I was like, this is working, this is nice. I'm actually getting some meaningful data out of it. So the next thing I was like, right, how do I now test this against all of my data? How do I actually map how in a chat log is happening, or the emotions in chat is happening over time? So also without using any code, that's kind of my goal in this case. So I went to get an export of Slack data. I used the YLD Slack, exported the public data from that. Public as in public channels to within the Slack group, not private channels or direct messages. Then I'm going to pull that data out. That comes as a load of JSON files. So I needed to change those JSON files into a CSV. So I used a tool called JQ to output a CSV file, run the model against the data, and then visualize it. So the Slack export was pretty much go to this link if you're admin, click download data. Totally didn't do this last night, might have done. But get a data of JSON files. It was about 10, 12 meg from all of our data. It said it was from the date range of 2018 to 2019. It lied, it did it back from 2014 all the way through, so there's a bug there. The next thing was to parse the JSON to CSV, and now I say it's not coding, I wouldn't call it coding, but it's not easy to do, right? So I kind of cheated here a little bit. I was like, I'm not going to write code, but one long command line argument inside of Linux is easy enough to do. So what I do here is cat all of JSON files, change the timestamps to a readable date. I then make sure I omit any items that have got an empty text field, and then basically create a CSV using text as the first column and timestamp as another, and output it to test.csv. So now I have a CSV piece of data. So the next thing I want to do is kind of clean some data up from it. Slack has this thing where you join the channel every time, so I want to remove that. The reason being, I'll give you a little hint here, is that when I went through the whole talk for the first time, I was like, sweet, but why are there spikes at certain points of time? I cross-reference the data and it incorrectly classifies has joined the channel as angry. And I was seeing spikes of angriness when there was a load of people joining new channels. So I was like, oh God, what's happening? Why is things really angry at this point in time? And that was what's happening. So I kind of was like, all right, yeah, this is why having clean data in both your training data and in the data that you are kind of parsing makes sense as well. I guess in the sense that my model needs to be better to handle those edge cases. So I should be really feeding that back in, retraining it with these kind of false positives and hoping to improve the model overall. But for now, let's just remove that data. And then I was like, how do I visualize this without using code? And it was getting late. It was about 10:30, 11 last night. And I was like, I can't do this without code. I was like, just basically started bashing away at my terrible Python. I don't write Python, didn't even know what I was doing. Lots of Stack Overflow, lots of just putting stuff together. So I don't know if this is nice or terrible. Let's skip this slide. But I basically ended up producing this chart, which is the plot of joy, anger, fear, sadness, love, and surprise from January 2019 to September 30th last night. And I was kind of surprised at kind of all the different spikes of anger as well here. So I decided to start looking through, and there was more and more points where I realized my model wasn't working correctly. Oh boy, tagged as anger. And then a massive, basically automated text messages from a bot saying that deployments didn't work, classified as anger, which I would assume would cause anger, but it's not really the intent that I wanted. So as I started to look through more and more, there's a lot of misclassifications and kind of realized that actually the model isn't as good as 90% as I thought it was. But it was a valuable learning exercise. So it's close enough. I was very happy how it is for a first draft. Given that this was all done in kind of a day and a half, I was super kind of happy with how it happened, being able to classify data roughly and get some kind of meaning from it. Yeah. So there's kind of next things is like, how do I improve kind of how the model is going to basically parse the data that's been inputted from the training data and from kind of the data that's coming in to be predicted. So Google have just, released a NLP framework or model called BERT, and apparently it has really, really high, I don't even know what I was talking about, but maybe someone who knows BERT can say what it is. It's basically good at NLP tasks.
It's the language understanding.
Yeah.
So it's pretty good at a lot of NLP tasks.
Yes, exactly.
Not the best now.
Not the best. Okay. Well,
you can't be running after the best because there is a new best every
exactly. Yeah.
But speaking of that, the Hugging Face, I think they just released the library in a Python, so you can just pretty much just apply it. You don't need to
Sweet.
do a lot of coding.
Yeah. So with Ludwig as well, they basically implemented the encoders and config parsers. So all you had to do was go to the Google Research BERT pages, download the appropriate model that you wanted with the hyperparameter size and embedding size. So that's what these kind of numbers here mean. And basically just link up the files with the appropriate pre-processing and config parse. They recommend, Ludwig recommend a certain learning rate and number of epochs to kind of warm up to make sure everything kind of flushes through and kind of gets up to speed. Started playing around with this, but because of the complexity of the model and time constraints to kind of do the same training, it was going to take much, much longer to kind of process the data because of the complexity of the BERT model. But it should hopefully provide better NLP meaning from the data so that we can kind of map that to kind of our categories much more strongly or with a better accuracy. So that's kind of my next thing to go on to try with and to see what comes out of it. So once I do that, the next thing is kind of to fix the model performance. So I want to kind of improve the test data, clean up the data input, and start kind of testing it against proper data. The next thing is like, I'd said that I wanted to try and have this happiness index, but in the end, I kind of was just plotting the kind of found categories. What I still want to do is kind of tag, kind of derive a meaning from the data to kind of have what is happiness, like how can you quantify that? And instead of it having a specific tag, have a kind of a weighted numerical meaning to if this is happy or not. So that's something that I wanted to kind of look at next, whether that's a different model or if that is the same model but with extra stuff added to it, I'm not too sure. Third thing, which is I wanted to build a bot so that it can kind of classify data as new messages are coming in. This is something that we kind of have in YLD already. So a previous thing that I created was a toxicity bot for some fun. And what that does, it classifies text based on toxicity of the comment. So if it's very toxic, what happens, the bot puts a little radioactive symbol as a, I don't know what it's called, a little note on the Slack message. And the idea is to eventually allow those kind of reactions, that's what it was, and feed that kind of reaction context back into the bot and make it self-learn. But again, haven't gone that far. And then hopefully move on to building a production model, but that's way off into the future. and kind of see if we can kind of predict any changes what happen which cause certain emotions to happen, which could be quite interesting from a predictive analysis perspective to try and see or understand when things are going to be less happy or certain other emotions happen at a certain point in time. Yeah, question at the back?
The next step is profit.
Profit. Oh yeah, the last one is profit. Nah. Hopefully, I mean, I would be able to get there, but we'll see. So yeah, if you want to contact me, Tom G Code on Twitter and GitHub. Web, either on my website or on YLD's. Email me at tom@yld.io. So yeah, thank you very much for listening, and if you have any questions, shout them out.